Okay, we are looking at the branching in the lung, so I pulled up another model here. Here's the one that we had that shows very good the trachea. This one shows the trachea, but this shows the bronchi very well. And then you see the bronchioles, so it branches into the right and to the left, major passageway, and then it subdivides, which you can't see too well on here, but on this one you can. You can see how it branches kind of like of a tree, okay? And there are, I think, 17 branches. That means it branches once, then it branches again, and it branches 17 times until you get to the area where you can actually have the oxygen in the air get into the blood and carbon dioxide get into it. It's a special structure that you would know, a functional unit of the lung called the alveolus, okay? And that's where the actual exchange takes place. So what happens is it branches, branches, branches. Now here's what most persons don't know. When you take the deepest breath possible, you cannot suck air into the portion of the lungs, the alveoli, where the actual gas exchange takes place. You can't do it. It only goes so far, and then it depends upon diffusion. And diffusion is kind of like in the previous video I said, if grandma's baking cookies over here, over there, because it's a higher concentration, we know it's there. So things go from high concentration to low, and that's what happens to keep you alive. So, I mean, that's pretty scary. Something that's passive transport, doesn't require any energy, is what's driving you getting gas exchange, okay? When I was a kid, what we would do is get in the water and take a garden hose and go underwater and try to breathe. And what you find out is quickly the hose would be so long you couldn't suck in air, and that didn't work, okay? So in the history of diving and figuring things that out, they had to figure out that the tube can't be but so long because you can only suck in air so far, and then it's diffusion, okay? When you have breathing, this is not muscle or tissue, so they are like captive in the pleural cavity. And they're kind of like this model. I mean, it's kind of cheesy, but you know. So they're the lungs. Let's say they're lungs, okay? So this right here represents the diaphragm, which isn't shown on either of these really, but it's a muscle that's right here. It separates your abdomen, the lower portion, from your thorax, the upper part. So this is the abdomen. So what happens is when you take a deep breath, see, air goes in, and then when you do like that, so you know when you want to get air in, you kind of tighten your abdominal muscles and air goes out, and then you do that. Okay, ribs are also important because your rib cage expands. So watch. Inhale, exhale, inhale, exhale, inhale, exhale. And since you're dealing with tubes and passageways, they need to not have a lot of junk in them, mucus, okay? And you don't want airway constriction. So things like black and mild or any kind of pollution, pollen can cause mucus to accumulate, and that's really bad. Now what happens is, it's kind of interesting, is that as mucus accumulates in your bronchial tubes, it knows how to come up and get out, because it's like rowing a canoe. You know how, you ever row a canoe? Okay, you have a power stroke and then a recovery stroke. You pull it this way, you don't keep it in the water and do that way. You do that and you do that. So that allows the water to go one way past the canoe. And that's what happens in your, you have ciliated epithelia, and on top of the cells or cilia, what they do is they do a power stroke and then they lay down and do a recovery stroke. Well, as you smoke, pollution or whatever, mucus builds up on top of it and they don't function too well. And since the passageways are so big, they become closed up and you have pulmonary obstructions. COPD is something you talk about when persons have it, and they have it chronic, you know, pulmonary blockage, okay? So that's how it works. Your lungs are trapped in the pleural cavity, and by using the diaphragm, that's how it operates. You can do CPR, of course, open the mouth and blow in. You know, that seems kind of yucky, right? Person vomited or foaming at the mouth. But what they found is, I think is really awesome, is when we did the blood circulation of the heart, when the blood circulates to the body and comes back to the heart, it still has a lot of oxygen in it. So the most important thing in saving someone's life is really keeping the heart pumping. And you don't, it used to be to this, blow, to that, they changed that, okay? Because it's pretty still loaded with oxygen, okay? So that's cardiovascular. It's really cool. There are cardiovascular exercises. Take it easy. Whenever you want to go out and do some cardiovascular and respiratory stuff, aerobic respiration, means with oxygen. Take it easy. Listen to your body whenever you're exercising. I exercise all the time, and if I've been away from it for a long time, I don't go in and try to be Hercules. You know, I just like take it easy. When I feel like it's getting a little, you know, tough, I just back off and go get a drink of water, you know, and then what happens is you get better and better. So persons often go out and they want to, like, you know, really rip it up, end up having the big one, have a coronary or something like that, and you don't want to do that. But again, being, you know, young persons, you should be fairly fit and you should work at your fitness. What you do right now for your age, 18, 19, 20, 21, 22, you are setting the pattern when you are 30, 40, 50, 60 years old. So you are determining right now what you're going to be like when you're like 10, 20, 30 years down the road. So unless you die, you're going to get there. So you want to stay fit as long as you can. So 2 systems, cardiovascular, and you want to think about your respiratory system, okay? And read the book again. Go to the iPad, you know, punch it up. I love the iPad. If I get my thing right. Let's try it again. Anyway, I punch it in and you can go to an animation, a simulation of how the lungs work, okay? And when you go to the hospital and to see Aunt Emma and she's in the bed, one of the things that you're going to see will be oxygen saturation, hemoglobin. That's what makes blood red. Is it saturated? Does it have like a really good high load of oxygen? And you're going to see heart rate monitored as well as breathing rate. So those are some very, very important parameters of all the parameters. So we're going to bring close to the respiratory part here, really great. And that's it.